Okay, good day everybody, back for the next video for the playlist on plate tectonics in the lockdown period. So this is more work that you would have covered already. All of this is repeating what you should have covered. We're just adding some clarity to the information. So where I left off last time was right here. We were talking about how this is what we're going to learn about, all these different faults and things we're going on to next. So we spoke about the theory of continental drift and what the evidence is to support that and how that worked and all that. Just a recap from previous grades that you might have done some work already on. So moving on. So let's talk about the different layers of the earth. So this is going to give you a bit more detail than you have in your textbooks and in your notes, but it's important to remember these things for the future when we continue this next year. So I've broken it down into more detailed layers than you need to know. So we have the crust. Everybody knows the crust. The crust is divided into two pieces, continental and oceanic, and we're going to go into detail on those two different types of crust in a few moments. But for now, we have the layer of crust. Then we have a layer called the mantle. So the mantle is actually split up into two types of mantle: lithospheric mantle and asthenospheric mantle. So those two words might scare a few people away, but just remember that you'll go further into higher grades. You'll talk more about these different types, but we'll talk about it a bit now too. So litho means solid, rock. It means rock. So we're talking about a more solid material, a harder material. Asthenospheric is referring to the part of the mantle that's more fluid, that's more softer material. So we have the crust, and part of the lithosphere is the crust, so it's the rock, harder material, the rocky material. Then we have the asthenospheric mantle, which is this red lines, and that's talking about the softer material in the mantle, the stuff that's more molten meaning melted. Okay, so then we have, it's shown here also, crust, mantle divided into different pieces of the mantle. Then we have the lower mantle, outer core, and then inner core. So here's a look at that again. Continental crust over there, oceanic crust under the oceans, and we'll speak about that in a moment too, a bit more detail. Then we have the mantle broken up into the lithospheric and the asthenospheric mantle, again just meaning that some parts of the mantle is not as soft as others, right? Here's just another picture of that, showing a cutout of the earth structure. So we have a crust, upper mantle, lower mantle, outer core, and inner core, broken up into different layers. But again, you don't need to know all of this detail for your current grade 10. Here's just another image to show you what that might look like at a different angle. Again, different types of crust and the mantle, more hard rock mantle and softer materials. So the continental crust varies about 30 to 40 kilometers. It's very variable, though. It could be much thinner than that, much thicker than that, but it is of a low density. This is important to know, that it is a lower density. Then we have the oceanic crust, which is much thinner at 7 to 10 kilometers, again variable also, but this is a higher density. So density means how many particles fit into the same space. So here we have more particles in the same block. For example, if we took a meter by meter block of the oceanic crust, and we took a meter by meter block of the continental crust, and we weighed those two blocks, this oceanic crust is going to be heavier than the continental crust, right? It's a higher density. It's like comparing a small block of steel to a small block of wood. The steel is going to be more dense, it's heavier than the wood, right? Okay. And then we have the mantle, lithospheric and asthenospheric mantle, which is quite high density too. So we looked at those plates earlier and how they're divided. Here's just another image of the plates. If it's not too clear, this is North America over here and South America over there, and we have the plates in all those different colors, right? Here's the African plate over there, and we have all these different plates. So there we have an oceanic plate, and here we have largely continental plate, and then oceanic and continental. So here's just a cool image coming from Marshak, or yeah, Stephen Marshak, portrait of a planet that I mentioned in the first video, the textbook. Here's some information about seismic activity. Seismic means earthquakes, right? So we're talking about earthquakes. So each of these dots represent some earthquake or seismic activity that's occurring, and you can see most of that activity is in this area between these plates, between this massive oceanic plate and these continental plates on the edges. And this is actually called the Ring of Fire. This is called the Ring of Fire because there's so much activity going on, so much volcanic activity, seismic activity, earthquakes that cause a massive disturbance to the countries and the people that live in the nearby areas. And we know that in San Francisco over there, a lot of earthquake activity. In Japan, in the Japanese area, in those subduction zones, a lot of earthquake activity, causing sometimes tsunamis, massive tsunamis. So this is called the Ring of Fire. So there's 4 types of plate boundaries that we're going to get into. We're going to get into them in quite a bit of detail. But we have transform faults. Those are your plate boundaries. Transform faults and MORs, which are the mid-oceanic ridges. Then we have subduction zones. And we see them all over the world. And the last one, continental collision zones. So we have transform faults, subduction zones, continental collision zones, and mid-oceanic ridges. So plate tectonics. What is plate tectonics? It's the Earth's crust and upper mantle broken into sections called plates, and they move across the hot mantle like a boat, like a raft. It's floating on top of that hot material. So again another image of the plates that we looked at. One is the lithosphere. So the lithosphere we spoke about is part of the upper crust and mantle. It's the hard stuff, less dense material, and because of that it floats. It's not as dense, it's lighter. Then the asthenosphere is the more plastic. We call it plastic, but it's not like a plastic bottle or anything like that. It just refers to the fact that it is rock, but it's so hot and under so much pressure that that material can move, right? Because it's more fluid, but it's not liquid. You have to remember that. A picture of all the different plate boundaries, a bit of a zoom in that we can look at. So here we have the mid-oceanic ridge where crust is created. We spoke a bit about that in the first video just lightly, but we'll go into detail. Then we have a subduction zone. Subduction means to go beneath, and that's what's happening here. This plate is going beneath the other plate. It's subducting against this plate. Then we have continental crust over here and rift zones where continental crust is being rifted away. Rift means to separate. So the crust is being separated, and we're going to look at a bit more about that in detail also. And then transform faults. You can see here the label, transform boundary, pointing at this line over there. That's when these lines are being separated. They're moving past each other from side to side. Here we have a plate boundary being separated, which is like at the mid-oceanic ridge, and here we have a plate boundary being subducted, which is over there and over here. But we'll get into detail, so don't worry about that too much yet. So 2 types of plates we spoke about, oceanic plates and continental plates. Oceanic plates are the plates below the oceans. This is a bit of a generalization, but we're going to get into that. Then continental plates, plates below the continent, also not actually correct, because the continental plates do have, the edges of the continental plates are often covered by the ocean. So, but we'll see that in a moment. So plate boundaries, we have convergent boundaries. That's boundaries between 2 plates that are colliding. Colliding means coming together, hitting each other, right? So there are 3 types of convergent boundaries, meaning there are 3 different types of plate boundaries that move against each other. Okay, so let's get into that. Type 1. Type 1 is the ocean plate colliding with a less dense continental plate. So we spoke about how the continental plates are less dense than the ocean plates, and when they are meeting, when they knock into each other, you get a subduction zone where the more dense plate slides underneath the less dense plate. I see I only have MOR there. It's supposed to be more dense plate slides under the less dense plate. And then we have a lot of volcanoes associated with subduction zones, and we'll get into some images of that now. So here we have plate A being subducted beneath plate B. So plate B is the continental crust and the continental lithosphere. So this stuff is less dense than the oceanic crust and the oceanic plates. So it floats over it, and when they collide, the oceanic plate, the heavier one, the denser one, gets pushed underneath. This piece is then pushed down beneath the lithosphere into the asthenosphere. And then I'm going to ask you guys some questions about that soon. But this causes the introduction of water molecules from that oceanic crust to be introduced into this area. And this bit complicated for your current grade, but we're going to get there. This is known as introducing a volatile. But all you have to know is that this causes the melting of the crust, and therefore the formation of these massive volcano formations along the coast over here, along that margin. So again, oceanic crust brings in these water molecules, which are then brought down to this area, and that causes melting of the crust in this area and the formation of magma and then lava when it comes out of the volcano systems. Okay, so continuing from there, the second type is a collision of oceanic plate and a oceanic plate. So we just had an oceanic and a continental. Now we have an oceanic and an oceanic. So the less dense plate of the two will slide over the more dense plate. Remember, these are both oceanic plates, so they have very similar densities, but one will be less dense than the other according to how old or young the oceanic plate is. This has to do with the temperatures involved of the plate itself. So this creates a subduction zone called a trench, and the most famous is the Mariana Trench. We'll get into that. So our next slide, if it allows me to do so, there we go, is showing that we have oceanic plate crust over here and oceanic crust over here, and they are colliding, and instead of any continental crust being involved, we have a trench created over there. You can see that line over there, and usually also associated again subduction zones, we have those volcanoes, and this is where you get those volcano islands forming, similar to what we have in Hawaii, where you have those islands forming because of volcanic activity. But Hawaii is a different case. But nevertheless, similar idea, melting, creating those volcanoes and islands from that result. So again, you have the more dense crust of the two oceanic crusts going beneath or being subducted by the less dense crust that goes above it. What's important to note is that point right there, where my point is at the moment. You can see how it's bent over and curved towards the movement that you see going down here. So that is where a lot of interesting, or rather devastating I should say, earthquakes occur. Not because it's any how people's houses are above it or anything like that, but rather because of the displacement of the water. So when that piece of crust gets under so much tension that it then shoots up and flings up and moves that water, that's the earthquake occurring, and it moves that water and displaces that water. That water has to go somewhere, and that's how you get oceanic tsunamis forming. So oceanic earthquakes creating those tsunamis, and we've seen it in Japan a couple of years ago, a devastating tsunami caused by the similar event. So you can see here being dragged the similar way down to the hot asthenosphere. So there's that question. If the edges of plate A suddenly flick upward, a large amount of water may be displaced. What could form at the surface of the sea because of this displacement? And I gave you the answer for that as well. This is a vital question you guys need to know. Then the third type, so we've had our first two types, this is the third one. Now we have a continental plate colliding with another continental plate. So again, type 1 was oceanic plate colliding with a continental plate. Type 2 was oceanic versus oceanic. Type 3 is continental versus oceanic. So this is where we have an area called a collision zone. So this is a place where folded and thrust fault mountains form. What this just means is that mountains are being built by these collisions, these continent collisions, and we're going to get into some examples of that soon enough. So here we see that. We see a continental crust being pushed upon another continental crust. And because these are harder materials, right, we're talking about rock and thick materials as well, it gets pushed up and squeezed and mushed up together, and these massive mountainous areas form. And we're going to get to some examples, the main one being the Himalayas. So the Himalayas on the Asian continent, the highest mountains in the world, Mount Everest, is part of that range, and it was created by the same process, and we're going to get into that. So South American Andes Mountains, the same way, and the Himalayas. Here you can see the Himalayas. So these areas over here are the Himalaya Mountains, with India to the south. The subcontinent of India, this region, was actually completely separated from Asia. It was part of Africa at one point, and it broke off, the plate broke off from Africa and moved northwards, and it crashed into the Asian continent and the Asian plate. Initially you can imagine that it first swallowed up some of that oceanic crust as it moved towards the Asian continent, and then it hit the continental crust, and we have this massive mountain range being formed because of it. And this is still happening today. This the subcontinent of India, the Indian plate, is still moving into the Asian plate today. You can see these arrows pointing towards each other, and that's creating that massive mountainous area.